News Unpeeled, thanks to 3dprint.com. And today we're going to talk about Simplify 3D. So at one point, Simplify 3D, came onto the scene, and a lot of people, especially kind of CNC minded type of people that understood that were coming from that background, really liked it. People loved the idea of being able to, or some people loved the idea of being able to just, you know, specifically use support or specifically create support where it was needed. And also a lot of people that came on that were new to 3D printing at that time bought it because, hey, simplify my 3D, that's exactly what I want. Simplify then grew, but lately it's kind of sent, it seemed to stalled. It was like Prusa Slicer got really good all of a sudden. Kira continues to do its thing. And simplified, yeah, kind of just seemed like it stalled. And if I was talking about it with friends, it's more like, yeah, maybe somebody will buy it, or what's happening? When will they have an update? Well, they have an update, and now it's simplified 5.0. Now, I have not test driven this, but I've not wanted to test drive Simplify 3D for a really long time, and this makes me want to test drive it. So, first off, they claim it's 3 times faster, always good. It's got automatic mesh repair for certain small errors, which you don't always want, but could really help a lot of people. There's an adaptive layer height function where you can change layer height, or the software will change layer height for you to improve the quality of the part, which I think for advanced users, but also for people new to the game, could be this could be a really, really amazing feature. By the way, going forward, if that gets better and better, then that could really change the way that we make and think of 3D printed parts. I really like this. There's a seam reduction, which for a lot of specific printers, we get these ugly seams at the back. Any kind of thing reducing that would be good. There's a thing they call target build customization. So essentially, what it means is, for example, let's say you have a really small perimeter, like a little small like ridge or something like that, or a ridge above a hole or setting or something like that. It'll just reduce the speed and then try to print the detail on the edge of that part as better as possible. You've got flow rate control, which again is one of those exciting new functions where we want to adjust flow rate optimally to guarantee speed, but minimize clogging and then get the best layer definition. So that's good. There's a whole offset compensation, which a bunch of other software on the professional side already had, but that's also really nice. And there's this dynamic infill density, which I believe is people have been doing this as well. But in G code essentially, or in by trying to kind of change the infill, depending where you want better infill, and to change the support level throughout that part, and maybe even change the geometry of that infill. So this is a feature that I think we need to do a lot more experimentation with, and I think would be really, really, very, very amazing. But in terms of optimizing prints, and especially if we go to a part where where you're printing like we're not printing a different thing every day, but we're going to print like 50 vases every day, and they're all going to be the same. Or we're going to do one build platform with 8 vases on them. We're going to keep printing that day in, day out. These kind of things can really, really change things. And also, if we're looking at variable density insoles or things like this, where we want to, at every single point in the foot, really give you a different experience depending on how you walk, that could be a huge thing for this. So it costs $199 for perpetual license, which may be a lot of money in one go, but it's perpetual. So if you believe in Simplify's future, let's say, then, well, that's not a lot of money to spend if it'll save you time and do some cool things for you. And definitely, like, out of nowhere, it's back. It's like all of a sudden it's relevant again. It's exciting. It's something to talk about. And I think for the industry, we need, the more slices we have with a sizable user base, the more kind of cool features we can see develop that can lead the way forward. We don't always know what we want, right? We don't always know what we want. Think of like things like Spiralize, which started as kind of a joke, is now used by a lot of people in production, right? So we don't really we're not a mature industry. We don't need the features we want. So multiple vendors competing against each other, trying to be better is really good for all of us, I think. So good news to this. Another bit of good news. This is wonderful. This is okay. Well, some of us will probably remember the Economist cover. There was an AOS violin on there made in polyamide using Compatible Fusion, and it really kind of used for this Economist magazine cover. And that was really the thing that got like absolutely everybody talking about 3D printing back in the day. And a big, big moment, right? A lot of people knew about 3D printing for decades before that, But this is the time when it became like a water cooler subject in most of the big companies in the world. Big moment. Now, after that, this whole idea of a 3D printed violin was kind of a cool test case kind of thing, but it never really went anywhere until the Acoustical Society of America's Aviva Young Artist Program and Mary Elizabeth Brown, who you see in front of us. And Mary Elizabeth Brown is thinking, you know what? I'm actually going to do this. And what she's been doing is she's using ABS, just FDM, material extrusion printing, and another technology. It's a bit of a the news announcement is in reference to a talk she gave in a workshop, so it's a bit light on the details. Two different plastics. One is for the ribs and the fingerboards, which is just ABS, and then the other one for the actual, let's say, the body of the violin, which is a different polymer, right? Reportedly, it's like a more mellow sound, whatever that means. It's a bit darker. But what she's trying to do, and this is wonderful, is just trying to make violin playing more accessible using 3D printing. Her idea is we can make these things really inexpensive. And we know, like, we can imagine how inexpensive this thing is. And we could just make it inexpensive. We can get more kids to play the violin because violins are cheaper. I think this is fantastic. It's wonderful news, wonderful work, and I hope she gets a lot more done and really, could develop a really incredible low cost 3D printer to, well, bring a lot of misery to a lot of living rooms in the near term, but in the long term, bring maybe some much more beautiful, much more democratized music to the world. I think that'd be absolutely fantastic. The next thing is also something I'm enthusiastic for. Like, funnily enough, all the news today is desktop 3D printing, and all of it is I'm just super happy with it. Next thing is Gantri. Now, Gantri, I think, is a fantastic company. What they do is they make kind of design items using desktop 3D printers. They have this thing called the Gantri plant polymer, which is kind of they say it's biodegradable, and I think based upon it, it's an impact modified PLA that maybe is based on what is a CSU PLA, but which has been made to be more biodegradable, more compostable than other PLA variants. I'm thinking it's that, but they could have just modified it in different ways as well. Maybe they're in the States, in California, so maybe it's just a NatureWorks PLA that they modified to make it more compostable or biodegradable, something like that. Anyway, they use their own material, they use their own kind of desktop 3D printers, and they've modified them, and they make design items. But what I love about Gantry is that they're really using desktop 3D printers to manufacture, which we know is super cheap, right? And they're making beautiful things. Like, this is a lamp. The lamp's called the Hula. It's made in a smart way that the LED light is directed upwards, to the ceiling, let's say, to make the lamp look kind of like bigger and nicer than it is, and to really make the room nice. And the light is also directed downward. At the same time, this light is directed in such a way that if you approach it, let's say you walk into your bedroom or you put your phone on the night table, it doesn't just glare and shine right in your face, which of course is really sucky if you're about to go to bed. Love kind of things like this. It's designed by Felix Pottinger. It's available in 3 colors. And yeah, it's made entirely in California, printed in California. And I love this idea of saying, look, consumer products with industrial 3D printers are too expensive, but what if we just use 100 Ultimakers or Prusas or 100 Crealities, right? Can we do this? And there are certain companies that are starting to do this. There are certain companies that are opening service bureaus with desktop 3D printers and there's other companies that are printing desktop products or desktop consumer products as well. And I think this is going to be a burgeoning kind of growth in this. We're going to see burgeoning growth in this segment, and I just don't know where it'll end. But I really think that, if you make your own PLA, right? If you convert your own PLA, you buy it from NatureWorks, you convert it into filament yourself, and then you operate a bunch of desktop 3D printers. All of a sudden, everything becomes really cheap. And these guys seem to have been able to, either through a finishing technique or adopting the PLA, I think it's a combination of both, and optimizing their 3D printers, have gotten really good layer definition. These products do not generally look 3D printed. So I think that's another wonderful thing they're doing. So love Gantry. Love what they're doing. Gantry, by the way, is spelled Gantri. Now, thank you very much for your time. My name is Joris Peels. This is another edition of 3D Printing News Unpeeled. Have a great day.